Today in this video I am going to explain Gaussian elimination method for solving a system of linear equations. So there are three linear equations to be solved. 2x minus y plus 3z is equal to 9, x plus y plus z is equal to 6, x minus y plus z is equal to 2. So first we write the linear equations in the form of matrices. So first matrix is written of the coefficients of x, y, z, that is 2, minus 1, 3, 1, 1, 1. Now here 1, minus 1, 1. Second column matrix of x, y, z. And is equal to the column matrix of the constant terms, that is 9, 6, 2. As you know well, this is the way to write a system of linear equations in the form of matrix. So in the matrix form we have written these three equations. Then by elementary row transformation we make these two elements 0. So blank matrices, third matrix x, y, z as it is, no change, and on the right hand side the matrix should be blank because the same operation is applied on the right hand side on this matrix. Whatever we apply on this matrix, so we have to make these two elements 0. The operation should be R2 minus 1 upon 2 R1, because half of the R1 is 1, then 1 is subtracted from this one, it becomes 0. The same on R3. Since R1 is operator and operator doesn't change, so write operator first, R1, 2 minus 1, 3, and on the right hand side 9 as it is. Now go on subtracting the half of every element of row 1 from the corresponding element of row 2. So half of 2 is 1, 1 minus 1 is 0. 1 minus, if we substitute R1, minus 1 over here, it becomes plus half, minus minus. So 1 plus half, that is 3 upon 2. And here R2 is 1, R1 is 3, so we have 1 minus 3 upon 2. 1 minus 3 upon 2 is equal to minus 1 upon 2. And now R2 is 6 and R1 is 9. So R2 we write 6 and R1 we write 9. So we have 9 upon 2, and taking LCM we have 2 6 are 12, 12 minus 9 upon 2, 12 minus 9 is 3, so 3 upon 2. Now come to the row 3. Here again we are using the same operation. Every time from every element of R3, half of the element of R1 is subtracted. So 1 minus 1, 1 minus half into 2, that is 1 minus 1, that is 0. If we write here R3 is minus 1 and R1 is minus 1, so minus into minus plus 1 plus half, so minus 1 plus half becomes minus half, so write down minus half. Now come to the next element, that is R3. The element of R3 is 1 and element of R1 is 3, so we write 1 minus half into 3, that is 1 minus 3 upon 2, that is minus 1 upon 2. Now here on the right hand side, R3 is 2 and R1 is 9. So substituting here, we have 2 minus half into 9, 9 upon 2. So 2 minus 9 upon 2, taking LCM, we have 2 2s are 4, 4 minus 9 upon 2, that is minus 5 upon 2, minus 5 upon 2. Now in this step we have to make this element 0 with the help of R2. We can't use R1 as the operator, because if we use R1 as the operator, this 0 will be disturbed, and in this method no 0 should be disturbed. So we have to use R2 as operator to make this element 0. So simply 1/3 of this element should be added to this, then we get 0 over here. So the operation should be R3 plus 1 upon 3 R2. Since we are not performing any operation on R1, so R1 should not be changed. So write down first 2 minus 1, 3, 9. And R2 we are using as operator, and operator never changes, so write down operator as it is 2, 0, 3 upon 2, 1 upon 2, 3 upon 2. Now perform R3 plus 1 upon 3 R2 on R3. So substituting R3 and R2 from here, both the elements are 0, so this 0 remains 0. And R3 is minus half, and here R2 is 3 upon 2, so 3 will cancel 3 and you will get plus half, minus half plus half 0. Next, R3 is minus half and R2 is minus half, so we will get minus half, minus half, minus, if you substitute 1 upon 2 over here, so minus into plus minus, and 1 upon 2 into 1 upon 3, 1 upon 6, see this like that, 6, 2 3s are 6, minus 3, minus 6 1s are 6, so we get minus 4 upon 6, 2 2s are 2, 3s are, so that is we have minus 2 upon 3, so here we have minus 2 upon 3. Now next, now come to the next one. Now R3 is minus 5 upon 2 and plus 1 upon 3 R2 is 3 by 2 over here, so 3 is cancelled by 3 and we have minus 5 upon 2 plus 1 upon 2, which is simply minus 4 upon 2 or minus 2, so we get minus 2 over here. Now after that we multiply these two matrices, so we get 3 equations. The first one is 2x minus y plus 3z, 2x minus y plus 3z is equal to 9. Second one, 0 into x, 0, 3 upon 2 into y, 3 upon 2y, minus half into z, minus half z is equal to 3 upon 2. This is, let it be second. And the third one, 0 into x, 0, plus 0 into y, 0, minus 2 upon 3 into z, minus 2 upon 3 z is equal to minus 2. That will be equation number 3. So now, from equation 3, we get minus 2 upon 3 z is equal to minus 2. So, transposing minus 2 upon 3 to right hand side, we get z is equal to minus 2 into minus 3 upon 2. 2 is cancelled by 2 and minus into minus becomes plus, and ultimately we get z is equal to 3. Now putting this value of z in equation number 2, we get, putting in 2, we get 3 upon 2y minus 1 upon 2 into 3 is equal to 3 upon 2. So we get 3 upon 2y minus 3 upon 2 is equal to 3 upon 2. And if we divide every term by 3 upon 2, we get y minus 1 is equal to 1. Transposing this one to that side becomes positive, and ultimately we get y is equal to 2. Now substituting the value of y and z in equation number 1. So we get 2x minus 2 plus 3, z is 3, is equal to 9, or 2x minus 2 plus 9 is equal to 9. This 9, these two 9s are cancelled because these are on the opposite sides of equality and having the same signs. So we get 2x minus 2 is equal to 0, or 2x is equal to 2, or x is equal to 1. So ultimately, thus finally we have is x is equal to 1, y is equal to 2, and z is equal to 3, which is a required solution of the given simultaneous equations by Gaussian elimination method. So this is the way to find solution of a system of linear equations by Gaussian elimination method.